Welcome back, ladies and gentlemen, to video number 4. This is your final and last assignment for the day. You should have this worksheet in front of you. This is to apply all the notes and all the rules or all the trends that we just went over. And so, take a look through these. Go ahead and complete number 1 all the way through 8. Then I need to go over number 9 for a little bit here. Number 9. Number 9. Here we are comparing ionic radius. Ionic radius, plurals, ionic radii. Okay? And if it's the same element, we already went over the notes for this. The cation will lose electrons to become it, so it's positive. It lost electrons, so it's smaller than the smaller. So, for example, A here, Na and Na plus. Na plus lost an electron, so it's smaller, so the one with the larger radius is Na. Okay? And then, if it's an anion, which is negative, it gained electron to become negative, so then therefore it's larger for the same element. It has to be the same element, chlorine, so the anion is bigger. So the question is, what if they are different elements? Let me get some paper real quick. What if they are different elements? So different elements, you are going to have to look at a few things, right? This is only for pre-AP, which is pre-AP. You have to do C through F. Okay, regulars you can stop there. Just know this this ionic radii here. Regular classes, chemistry classes for Miss Carrasco. It'll be period 3, 7, and 8. Yes. Period 1, 4, and 10, you have to do these. You have to know how to do these. Number 9, for example, 9C, right? We have Mg plus 2 or Na plus. All right. And so what do we need to compare? So if you look at the periodic table, Mg looks like this. Mg and then Na. Look at the periodic table. I don't remember. Mg is 12, atomic number 12, Na is atomic number 11. So in the nucleus of this Mg, move this. In the nucleus of this magnesium, there are 12 protons. In the nucleus of this sodium, there are 11 protons, because that's what the atomic number tells us. Okay? 11 protons versus 12 protons there. Alright, so Mg is on row 3. Okay, row 3. So it's going to lose 2 electrons to become that. So it's going to have, it's going to lose 2 electrons, so it's going to have 10 electrons on the outside. And sodium will also, it's going to lose 1 electron to become positive 1. So it's going to have 10 electrons on the outside also. So, which one will be smaller? Which one will be larger? So, 12 protons are going to pull a lot stronger than 11 protons. Okay, 12 protons are pulling stronger. So this one, the magnesium 2 plus, is smaller. The sodium is larger. So that's how you determine those. Okay, compare. So compare, the direction here is compare the proton versus the electrons for both atoms. And whichever one has more protons pulling, they will have the smaller atom. Okay, with less protons pulling, so the electrons are a little further apart. They can roam a little more freely, so they are larger. For the same number of rings, of course. And these are all designed so that they do have the same number of rings. Yes. So that's really all you need to know for that one. It's fairly simple, but You have to understand it. And then you go to the back and complete the back as well. And for these, again, just a quick review here. Let me go over number 10. Rank the ionization energy. Remember, ionization energy is energy to remove electrons from the outer shell. Electrons remove an electron, so therefore smaller one, higher energy, more energy because they're close to the nucleus, and the larger one, lower because the electrons are far. Electrons, you can snatch it out easily. Okay, lower energy. So, for example, let's pick D. No, that's kind of easy. E. Okay, B S I P. B S I P. Okay. Sorry, it's a mess on this periodic table, but just pay close attention. Here's B. Here's Si. Here is P. So which one is the largest atom? The largest atom will be the lowest ionization energy. The largest atom is got to be on row 3 because it's got 3 rings. Okay, 1, 2, 3. Row 2 only have 2 rings, so boron's going to definitely be the smallest. So boron's going to be the highest ionization energy. So boron's last. And we have the other 2 that goes there. So boron's last, then we have the other 2 that goes there. Si and P, which one's smaller? P is smaller because it has one more additional proton pulling on it, so P is the smallest, so P has the highest ionization energy, and then Si. P-Sib, yo. Alright, finish this, complete this. Your teacher will have the answer key with them, so if you want to check, go ahead and check it out with them, and they will help you out. Okay, to make sure you get this done. Good luck, have fun. After you get these done, fold it, put it in your pocket. And for Ms. Carrasco students, after you finish, show it to your teacher, and she will check that you have completed and put a grade for you, and we will enter those grades into the grade book for you. You all have a nice day.